A rectangular garden has dimensions of 5 meters by 7 meters. When both dimensions are increased by the same length, the area of the garden increases by 45 meters squared. Determine the dimensions of the larger garden. So let's just draw this thing out. Okay? So here is the original garden. We know that it is 7 meters by 5 meters. I know that that means that it's 35 meters squared. So we're going to increase by the same amount on either end. So here's my 7 meters. But then here's an extra increase. That's the exact same length as the increase in the width. So actually, the dimensions of this are going to be 7 plus x. And the dimensions of this are going to be 5 plus x, because we're adding the same increase. Now, as we have introduced a new variable, let's define it first. So let x represent the increase. We know that the increase of the length and width have resulted in an increase of 45 meters squared. So that means it's 35 meters squared plus 45 meters squared for a total of 80 meters squared. So we know that the area is 80 and my two sides, length times width, are going to be 7 plus x times 5 plus x. So we're going to approach this the exact same way as we would do any problem when it comes to quadratic equations and solving them by factoring. We're going to expand it out. 35 plus 7x plus 5x plus x squared equals 80. And I'm going to do a little fancy footwork and do a few steps here at once. So x squared plus 12x plus 35 equals 80. X squared plus 12x minus 45 equals 0. So now we've got to come up with two numbers that multiply out to negative 45 and add up to 12. So when we factor this, we're going to think of that. So two numbers that multiply out to 45 and add up to positive 12. I think that's going to be x plus 15, x minus 3. So that means that the x could potentially be negative 15, and the other x could potentially be 3. Hold the phone though. Can a length ever be negative? Could this be negative 15? That would represent, if it was true, that would represent a decrease, not an increase in length. And so we can just immediately, based on the constraints of real world, say that x cannot equal 15. Sorry, x cannot equal negative 15. And let's see here. If I would say x equals 3, I can just visually go here. Okay, 7 plus x. 7 plus 3 is 10, so one length would be 10. 5 plus 3, one length would be 8. 10 times 8 is 80. So I know just by looking at the constraints of the problem, or the parameters of the problem, that the only thing that could potentially, the only answer that would work is x equals 3. And we're done. Haha, except not yet. What we need to do is we need to figure out what the dimensions of that larger garden are. So the dimensions of the garden are 7 plus 3 by 5 plus 3, which is 10 meters by 8 meters.